what we want. Our
In this course, we're going to be covering all of the things you need to know to test your pipelines in development. Too many quality errors are caught in production or even later in a dashboard. And in this course, we're going to be talking about how to unit test and integration test your Spark pipelines so that you catch the errors in development before you deploy to production, and it causes a lot fewer headaches for you to deal with later on. So if you want to start building your data pipelines with a software engineering mindset, this 2-hour course is for you. And if you're interested in learning how to deploy these pipelines in the cloud, you should check out the dataexpert.io Academy. There's a link in the description below where you can get 20% off. I'm excited to see you there.
a quality bug, like where can you catch quality bugs? Usually there's going to be three cases. The first case is you catch the quality bug in development. So when you're writing the pipeline, you catch the bug, and then you fix the bug before you deploy to production. Which is great because then it's like almost like the bug never existed because the bug never surfaced to anyone, and like you don't have to talk about the bug, you don't have to like do a post-mortem about the bug. You can just freaking like fix the bug in development and be on your merry way. That is the best case scenario. It's beautiful. I love catching bugs in development because that just means it's one less bug in production. Then you have two ways that bugs show up in production. One is when you're doing write, audit, publish, and what happens is you write to a staging table, and then you run your audits, and your audits fail, and then you don't end up publishing to production because your audits failed, and then you have to go and troubleshoot why. And this is something that you want to like minimize the amount of time that you're doing, because this can be kind of onerous on your data engineering teams, especially if you have like a ton of production data quality. Minimize the amount of time that you're doing, because this can be kind of onerous on your data engineering teams, especially if you have like a ton of production data quality checks that false positive. And then it's like, I hate false positive data quality checks. They are common. And so these types of checks are more expensive in that regard than the ones that catch stuff in development, because of the fact that you have to check them out in production and they can fail and false positive and all these other things. And then the worst case scenario is that you have a quality error that bypasses your quality checks and ends up showing up in production. And usually how you learn about this is, too far. There we go. Usually how you learn about this is a data analyst hits you up and is like, yo, why does this data look weird? Or there's a dashboard that has a spike, or there's some sort of anomalous thing like that happens. And sometimes these errors actually go unnoticed for weeks at a time, especially if they're more nuanced errors, then they can go unnoticed for a substantial amount of time. So definitely know that you can have bugs that persist in production that you aren't as aware of. Three ways to catch quality bugs: in development, in production, but not in production tables, and in production tables. The last one is the one that you want to avoid because that's the one that damages the company. The other two, like the middle one, is better, but it's still kind of like is a little bit stressful because you have to like troubleshoot something that's in production and it causes a data delay. Right, data ends up being backed up, and like some people might complain to you like, why is the data behind? And it's like, oh, it's because it failed a quality check. So, and then obviously catching in development's great, and we're going to be working in the lab today. We're going to be working on that first one, on like how to actually create test cases for stuff in development. Okay, so how do you catch bugs in development? That's probably, I was just talking about that, like what is the right way to go here? So there, obviously you can do two types of tests. So you have unit tests and integration tests for your pipelines, and they both are very useful. In this case, you could think of a unit test as if you have like UDFs in your code, or you have like in Spark, say you have like a specific function that like does a lookup or does something like that. You want to write tests for each of those like individual functions. That stuff is very powerful, especially and critically if those call another library. Like for example, one of the things for me when I was working in pricing and availability at Airbnb is I had to integrate with the pricing and availability libraries that Airbnb used. And so my pipelines would need to call those pricing libraries, but they can edit, right? They can like I'm not in control of those libraries, and the team that is in control of those libraries can change them. So one of the things that's very powerful if you do write unit and integration tests is if you depend on somebody else's code, then if they change that code and break your test, they have to fix your test before they can merge, because it will break your test and then they can't merge because CI/CD will fail. And so that's a very powerful thing that you get from unit tests, is they actually allow you to safely depend on other people's code, and then the other people don't even need to know about your pipeline. They just need to know that like, hey, like this, like if I make this change, things are going to fail, right? You can catch bugs in dev, right? And you mostly catch them with tests. That's going to be the big way that you catch things. There are other kind of important ways that you can catch bugs in dev. I'll talk about just quickly here. One of them is going to be around having a linter. So lint is a way to enforce coding standards. So you might not be able to catch a bug this way, but it makes your code more readable. And if you make your code more readable, you're more likely to spot bugs. And it forces everyone to code to the same standard and the same style. So definitely look at how to implement a linter into your coding environments. And that will force everyone on your team to essentially code the same way. I do that for exactly.com and a bunch of other places so that like whether it's me writing the code or someone else writing the code, we're all going to do the same like thing, right? The same standards of like spacing and variable names and all sorts of stuff like that. So anyways, that's how you catch stuff in dev. Let's go to the next slide. Okay. Well, production's pretty straightforward to catch stuff, right? You use write, audit, publish. We're going to be covering write, audit, publish in painful detail on Thursday so that y'all can like have a lot clearer picture of how all that stuff works. There's another pattern called the signal table pattern that we will also cover on Thursday that is similar. I think it's less good, but Facebook actually prefers the signal table pattern over write, audit, publish, but they both work. And so definitely know that like essentially how this works is you write your data to like a test table or a staging table that has the same schema as your production table. Then you run your quality. Essentially how this works is you write your data to like a test table or a staging table that has the same schema as your production table. Then you run your quality checks, and if they pass, then you move the staging data into production. And so that's kind of like how write, audit, publish works. And so that's how you catch stuff in production. And then so what's the worst situation, right? The worst situation for data quality is the data analyst will be they find bugs in your data and then they yell, nobody wins. And so this is the situation that we're trying to avoid. Obviously, you could have even more painful situations where the data quality bug is not discovered and then bad decisions start happening. That's definitely something that I noticed when I was working at Facebook. There was definitely like a quality error that caused too many accounts to be labeled as fake for a while, and that kind of like hid under the surface for a bit until someone discovered it. And so in those situations, that's even worse, right? Is once you have people or algorithms are starting to make decisions based off of bad data, that is the absolute worst case scenario, because then you're actually making a negative impact on the world. And that's something we're also trying to avoid. This is like essentially the last bastion of data quality, is if the data analyst happens to find it. But you can't rely on manual queries to enforce your data quality standards, because that's like not scalable, also not reliable, also just like that's just not what a data analyst is about. A data analyst is about finding insight from data, not finding bugs in data. Obviously, they can do both, because that's like kind of like you have to be able to do both because of like the data cleaning requirements of the jobs nowadays. But that's kind of the idea behind like how this stuff can really go apocalyptic. And so definitely understanding what we can do as data engineers to avoid the apocalypse is great. So yeah, well, now I'm kind of done talking about the apocalypse. Let's talk about something a little bit lighter mood. This slide, right? Software engineering actually has higher quality standards than data engineering, and that might sound bold to some of you, but it's 100% true. I found this to be the case, especially as I transitioned from when I was a data engineer at Facebook to a software engineer at Netflix. Just the amount of testing and requirements and all of these things that go into software engineering and building live systems is just, it's different. It's like it's like an order of magnitude more quality in tests than in the data engineering domain. And I think one of the things that's going to happen in the future and is already happening is a lot of these data engineering jobs are going to need to adopt a lot of the quality standards that you find in software engineering, especially where people are building production systems. So yeah, let's go into like why that's the case, right? Because that seems kind of strange that software engineering would have more quality standards. So software engineering has, higher quality standards. Why? Okay, let's just go over the big ones. So if Facebook, the website, goes down, does Facebook lose more revenue from that? Or if a data pipeline that powers notifications goes down? So, I mean, obviously, I would think that if people are not accessing the website and they're not being served ads, that's going to cause a problem, right? And a lot of times in data, like, it's okay if things break, even for a day or two, and because you can just use stale data or data that's a little bit older. And so you have to, like, when the consequences in software engineering, when things break, is generally an order of magnitude or two higher than the consequences of things when they break in data engineering. And especially like in terms of like response times, like if you are a software engineer working on the Facebook website and then the Facebook website goes down, you need to respond to that at 3 a.m, right? And generally speaking, like for me, if a data pipeline breaks in big tech at 3 a.m, I can wait. I can wait until 9 a.m. or 10 a.m. I can wait till I'm back at work and I don't have to troubleshoot it in the middle of the night. And I think that's another big important difference between software engineering and data engineering is the fact that you have to really, in software engineering, you have to have all your bases covered because there isn't as much tolerance for risk as there is in data engineering. And like, it's a good thing. I mean, that's one of the things I like about data engineering as well, because like having to deal with shit where you freaking wake up at 3 a.m. to troubleshoot on call, like, okay, like that's an issue, right? So I think that's a big one. So you can think about risks. So like for software engineering, there's an immediate consequence for lack of quality. There's an immediate consequence of a bad push. There's an immediate consequence. Think about risks. So like for software engineering, there's an immediate consequence for lack of quality. There's an immediate consequence of a bad push. There's an immediate consequence of a quality issue. And so that's a big thing. I think a second area is software engineering is just more mature than data engineering. It's been around a lot longer. Data engineering has only been around like 10, 15 years, whereas software engineering has been around, I don't know, like 50 years. So big difference there. And especially test-driven development and behavior-driven development, like those two types of development in data engineering are very new. And they, for a lot of people, they are not as aware about these other types of development. Whereas like if you worked in Agile at all, or you worked as a full stack engineer or anything like that, then you are at least aware of test-driven development, if not also behavior-driven development. So those things are things that are going to be more common in data engineering going forward, especially for the data engineer, software engineer archetype, because our data needs to have the same quality standards as our servers do. And so, and just because the risk is lower if they break doesn't mean that we shouldn't hold ourselves to a higher standard. And because that also allows us to have better guarantees and increase trust and open up new capabilities if we can hold ourselves to a higher standard of quality. And one last piece of why data engineering and software engineering have different backgrounds or have different levels of quality is data engineers come from a much more diverse background than software engineers. Like you have data engineers who came from software engineering. That's me. I'm a Swede EE. I talk about that. I make that joke all the time, like I'm a Swede, right? And then you also have people who came from data analytics, who are like data analysts, data engineers. Those people generally have less coding breadth and they have less of the software engineering fundamentals, obviously because they didn't come from software engineering. But then you also have people who come into data engineering from like other areas, right? I mean, I've seen people who are like economists and freaking all sorts of different other places as well. Whereas like software engineers usually like are a lot more likely to just come from like, oh, I have a computer science degree and boom, done, right? So, and because of that, like data engineers are going to be more variable on their own software engineering fundamentals. And that's fine because data engineering doesn't need the same level there. But like my whole point of talking about this at all is that data engineers that do have these strong software engineering fundamentals are going to be able to up level the quality and maintain really good standards for their data pipelines going forward into the future. So that's kind of my perspective on like why software engineering is higher quality. It's mostly like from one angle is because it has to, from a second angle it's been around longer, and from a third angle the people coming into the field in data engineering have more of a diverse skill set that doesn't necessarily include a lot of these like software engineering fundamentals. So how does data engineering become riskier? This is a good one. So when I worked at Airbnb, I worked with this machine learning algorithm called smart pricing. Smart pricing, for a lot of hosts on Airbnb, they don't even pick prices at all. They let AI ML do it. And I was responsible for the data that fed into that algorithm. And that algorithm was responsible for a very large chunk of Airbnb's revenue. And so one of the things that we knew was, okay, if this model is trained on data that's 1 or 2 days delayed, how much do we give up? Like what percent of revenue do we lose for every day that the data is delayed? And that's something that we went over and we like measured that to understand like, okay, what are the risks and like how much like can we be okay with when we are working in the data domain to do these things, right? And so, like, that's a big thing to think about, right? And that's like another reason why these things are different is because in software engineering, when there's like a delay or something broken, a lot of times it's not like a 10% drop, but it's like a 100% drop. Whereas in data engineering, a lot of times as your data gets more and more stale, you see a rapid, like kind of a slow and then rapid degradation of the effectiveness of your models. And so that's a very important thing to think about when you are building out your pipelines is what is the consequence of something breaking and how do I mitigate that? And so big important thing there. Another one here, data quality bugs that impact experimentation. So if you have data quality bugs that are persisting and they're kind of hiding out because like you aren't doing enough checks, what can happen here is in the experimentation layer, when data scientists are running A/B tests, they might get the wrong idea because there's a bug in one of the metrics, and they might be like, "Oh, this experiment was a success," or the other way around, this experiment was like there was no impact when there actually was an impact, and so that can be another like thing where like bad data can impact the quality of decisions that are made. It's an important thing to think about. And lastly, here is like we have data-driven cultures, and hopefully we are, as data engineers, we are spearheading that idea of we need to be more data-driven and or data-informed, data-driven, whatever words you want to use there. And as we rely on data more to guide our decision-making processes, the more risk there is in data quality issues. So it's like as our impact as data engineers rise, we need to hold ourselves to a higher standard because people rely on us more. We have more responsibility. We are carrying a bigger weight of the company on our shoulders. And since that's the case, like we have to up level our game. We can't just be writing SQL queries that dump garbage into the lake and call it a day. Like we can't do that anymore. We have to take our skills to the next level. We have to really go and build things that actually have provable quality constraints. And that is going to be so important for data engineers in the future and going forward. So remember that, like, data engineering is going to get riskier, and especially as you climb the ladder, as you become like senior and staff engineer, you're going to be responsible for pipelines that are riskier. So that's like just like how I was talking about smart pricing at Airbnb. That's like the reason why I was responsible for that was because I was a staff engineer. I was like a pretty high level engineer at Airbnb, and when you're a high level engineer, they give you the riskiest stuff. So definitely that's where having good fundamental knowledge here around quality will also help you minimize the impacts of quality errors and issues as you progress throughout your career as well. Let's talk about like why organizations miss the mark. So many places I've worked at, they don't do quality right. They don't do it right at all. So for example, when I worked at Facebook, I didn't, like, in my first 18 months, I worked at Facebook for 2 years. So in my first 18 months at Facebook, I didn't write a single data quality check. Not a unit test, not an integration test, not a production data quality check, nothing. Like, didn't write anything. So it's like, and sometimes I think some people might find that surprising because they're like, wow, like why are like isn't Facebook like a very technical, really awesome company? Like, why are you not like actually caring about quality? And one of the reasons for that is at Facebook they have this whole tenet of like move fast and break things. It's a very important part of the culture at Facebook, was like we need to iterate quickly. And that put a lot of pressure on the data engineers to actually build pipelines as quickly as possible, which made the quality check part was kind of a nice to have, kind of like one of those things that's like, whatever, we don't really need it. And data analytics is more about answering questions as quickly as possible. And that's how you like win. That's how you get your impact, is you answer questions as quickly as possible. But it doesn't have like data analytics and software engineering here do not have the same culture, because software engineers are all about building something that lasts, and data analytics is all about answering questions quickly. And like they both like you can actually have both. That's one of the things that I think we're starting to realize in data engineering, is that you can build high quality data sets that last and answer questions quickly. You can have both. Like, you don't have to like pick one, right? Even though they seem like they're competing, but they're not competing as much as you would think, especially on a long enough time scale. Like, if you look at it on like a 1 month time scale, obviously there's going to be competition. But if you look at it on a 2 year time scale, they should be together, because if you want to go quickly, right, cut as many corners as you want. But if you want to go far, do everything right, do automated excellence, have all your tests, right? And I mean, that was the other thing at Facebook that I thought was crazy was that like when essentially how quality errors were caught was the analyst would be like, this chart looks funky, what's going on here? And then we'd spend 5 days digging into like what the hell is going on, and then I would update the query and backfill, and then that would be it. And then I wouldn't like add any quality checks or anything like that. That was just bada bing, bada boom, done. And I don't think that, and honestly, these things, like these behaviors that I'm talking about, are definitely contributors to why I left Facebook, because I was like, why are we just like running around with our like chickens with our head cut off, like, and not like just jumping from quality error to quality error? Like, is this really the best way that we can possibly do this? And I don't know. I think that it's pretty clear that the answer to that question is no. But that's what I'm saying is that like even Facebook, a company that has enough engineers, who has some of the best engineers in the world, missed the mark here on data quality. So this is a hard problem to get right. And so definitely understand that that's the case. Just like I was talking about in the last slide, there's a trade-off, right, between business velocity and sustainability and quality. Like sustainability and quality are pretty linked. And so, because the business wants to answer questions as quickly as possible. They want to be like, yo, like, I need this answer yesterday. And then they're like, can you quickly pull this data for me? And then the data engineer gets angry because they're like, dude, this is not like an easy, quick thing to do. And so, like, how do you decide, like, do you answer questions quickly, or do you avoid making tech debt, or do you kind of do something in the middle? And so I've found when I've been working in big tech, when I have like strong managers, and I have managers who know how to protect like their reports, that you usually index more heavily on not creating tech debt, and you go a little bit slower on answering business questions. And then when I've been working with more weak leaders, or leaders who don't understand how to push back, then essentially analytics just eats the data engineer's lunch, and you get burnt out. And I've been there. That's was a big part of what happened near the end of my time at Facebook, and why I quit. So definitely, both sides of this can happen, and you'll find kind of contention on either side. That's where you want to definitely learn how to push back, right? And don't just solve every ad hoc request and jump from like little pipeline to little pipeline. Like, that's where you need to have a more robust data model. That's so important. And I hope that y'all learn some stuff from weeks 1 and 2 to help y'all build more robust data models. But that's kind of the idea. And my perspective has changed dramatically. And now I believe that, like, yeah, you should very, very, very rarely cut corners to answer a question faster. Unless it's very obvious that it's a one-off and that you're never going to answer, you're not going to need this question to be answered again and again. If it's that case, go and do it as quickly and sloppily as you want. But like, if it's anything else, which is 99% of the data that you're going to create, you want to do it the highest quality way that you can, so that it sticks around, right? Because that's one of the things to remember is, as data engineers, like, we're building roads and highways. We're not answering questions. This is something that I think people get wrong, is we're building information roads and highways. And do you want to build like a shitty dirt road, or do you want to build like a huge highway that can answer questions in a way more information rich and high velocity way? Or do you want to build a little dirt road that people complain about the bumps and the edges on? Obviously, you can build a dirt road a lot faster. You can build a dirt road way faster, right? And you just throw a couple of rocks and some gravel and you're done, right? Whereas like building the information superhighway takes a little bit longer, but it reaps more benefits over the long term. And I mean, even after like 6 months to a year, if you really have your team focus on this stuff, you'll start to see the benefits of doing it this way, as opposed to just like fighting the dirt road. What I'm trying to hammer in here is data engineering is engineering. It's not analytics. It's not like it. And this was another big thing at Facebook that bothered me a lot, was that at Facebook they have the individual contributor track, and then they have the engineering track. And data engineers were not on the engineering track; they were on the individual contributor track, which I was like, that is so ridiculous and so stupid and so dumb. And so that's another reason why I left, because I was like, I'm an engineer. I'm not an individual contributor. That's like such a weird way to like word things. So remember that like you want to be building things. Like, we're building powerful infrastructure for answering questions. And that is not the same as being a SQL monkey for the data scientist or being a SQL monkey for the data analyst. It's not about that, like, because that's not how you build powerful, robust systems. So keeping in mind that data engineering is engineering. And I mean, y'all are on the infrastructure track or the combined track, so I hope y'all probably agree with me on that. Some of the people on the analytics track might not, but so that's kind of the idea for this. And since it's engineering, we're trying to build cool stuff. Since it's engineering, usually things that are engineered get better and better over time, right? Because if you think about like the first Tesla, right? The Roadster, and it was like super expensive, and it still went pretty fast, but it was super expensive. And then it kind of iterated and it got cheaper and faster, and then like self-driving, and like they keep engineering more stuff into the Tesla, right? And it's like, wow, like that is freaking nuts. So like that's one of the things that I don't like about the narrative that like data engineers are just trying to answer questions, because that like narrative really doesn't really speak to the fact that we're engineers too. And here are 4 different ways that we are going to be creating more value over time as data engineers, right? So you have latency. Latency, we're going to be moving pipelines from batch to streaming or batch to micro batch. So that like